Dear students, I am here again with another video on the next experiment, that is on full wave rectification. So the aim of this experiment can be written as study and analysis of full wave rectifiers. So here I have again used the same virtual lab platform that had been used for the previous other experiments. So if you open the link for full wave rectification, this window will come up. There is, you'll find this experiment, there is full wave rectification here on the top, and the theory along with the objectives, what is a rectification process, what is a full wave rectifier. You can see again this input sinusoidal wave and the output rectified wave for a full wave rectifier. And finally, after these waveforms and various other content related to this full wave rectifiers, you can also have this bridge rectifiers. These all things have been already discussed in the theory classes. So you can then calculate the ripple factor in this, and you can also calculate the total output efficiency of the full wave rectifiers. So coming to how to perform the experiments, you have to come to the procedure part. You can see what are the steps in this procedure. You have to set first of all the resistance, that is RL, that is load resistance. Then click the on button to start the experiment. It is same as your half wave rectifiers, the same experiment that we have performed. Then we have to click on the sine wave button to generate the input waveform. Then we have to click on the oscilloscope button to get the rectified output. We can vary the amplitude, we can vary the frequency, that is volts per division, using the controllers provided. Then we have to click on the dual button to observe both the waveforms. If you want to see both the input and the output waveforms, okay, you have to press this dual button. Then you can calculate the ripple factor. So let's come to the simulation here. Let's open the simulation. If you open or click that link for simulation, you will find these two buttons. So this is a link for that full wave rectifier. You can click on this. You will obtain this type of circuit, or you can say this window will pop up. So first of all, you have to as given in the procedure or given in the instructions, you can see first of all you have to set the value of load resistance. You can set the value of load resistance RL. So let's keep RL equals to 300 ohms. Then you have to click on the on button to start the experiment. Just click on the on button to start the experiment. Okay. Then we have to click on the sine wave. Finally, let me check the instructions. We have to click on the sine wave to generate the input waveform. Let's click on the sine wave. So this is your input waveform. If you want to shift its position, if you want to change the time divisions, okay, so it can be done through these controllers. If you want to change the frequency, then you can change it using this controller. If you want to change the amplitude, you can use this controller. Okay, so all these things can be done using this this virtual lab platform. So here coming to The next button, that is oscilloscope. If you want to see the output waveform, you can click this oscilloscope. You'll find the value of peak current calculated here depending upon the various parameters, and you'll find the rectified output waveform here. Okay, so let's change the frequency of the input wave, and if you want to exactly understand, let's take one cycle, or let's take 2 cycles. Okay. So now again let's check the output. You can see the peak current value, and these are the rectified output waveforms. So you can calculate the ripple factor by using this formula given for ripple factor, and you can trace this output waveform, and you can keep it in your lab records, and you have to write this experiment as as it has been instructed in the first video regarding how to prepare the lab records. Thank you.